All right, the purpose of this video is we're going to do a run-through of the types of problems you're responsible for from today's work involving basic right triangle trig. So as a quick reminder, SOHCAHTOA is a very common way of this being taught in terms of a memory device: the sine of an angle, opposite divided by hypotenuse, cosine of an angle, adjacent over hypotenuse, tangent of an angle, opposite over adjacent. All right, for example number 1 here, they're telling us that this angle down here is 47.8 degrees. They're giving us that length and are asking us to find this length. All right, so our angle of interest is the 47.8. In relation to that angle, that's the opposite, that's the adjacent. So the trig function that uses opposite and adjacent is tangent. So I already have the equation written here. The tangent of that angle is 4 over x. So now we need to solve for that x. Okay, when it has this orientation of the variable on the bottom of the fraction here, it's always that number divided by this trig function. So what we're going to type in our calculator is 4 divided by the tangent of 47.8. All right, always check your mode. The TI graphing calculators will default to radian mode. So we need to be in degree mode. So that's the first thing I'm going to do is make sure I'm in degree mode. Quit out of there. Type in 4 divided by tangent of 47.8. Okay, follow whatever the round off instructions are. We get an answer of about 3.6. All right, next example. They're giving us this angle, the hypotenuse, and we know the length of this side. So in relation to that angle, that's the opposite, that's the hypotenuse, so we're going with sine. The sine of 32 degrees is equal to x over 3. When the orientation of the equation is the variable on top, it's always this number times that trig function. So x is equal to 3 times the sine of 32. All right, I already know my calculator is in degree mode, so I don't have to worry about that. So we get 3 times sine 32. Following the round-off instructions, we get an answer of about 1.6. Now, for both of those problems, I didn't close parentheses after the angle that we're taking the trig function of because there's nothing else happening. The 8384s don't require you to close parentheses in situations like that. Now, for some reason, I decided to type this in as the sine of 32 times 3. Then I'd have to make sure parentheses get closed there. Otherwise, the way the calculator would read it, if we didn't close parentheses, it would be taking the sine of 96 degrees, which is clearly a different answer. All right, back to these types of problems here. This is our angle of interest. That's the adjacent. That's the hypotenuse. So we're using cosine. The cosine of 36 degrees is equal to 8 over x. When the variable is on the bottom, it's that number divided by this trig function. Make some room here to do this. So we have 8 divided by cosine of 36, and we get a length of about 9.9 following the round-off instructions. All right, next example. Sometimes you're not given a diagram, you're just given a description of what they're asking you to find. So what I'm going to do is just draw a generic triangle. It says in the description specifically that C is the right angle. So over here we have A's and B's. It doesn't matter which we call which, as long as we label the rest of the triangle accordingly. And unless you're specifically told otherwise, the little a is always across from the big A. So the little a of 8.5 is referring to a side. That's across from big angle A. So that's over here. Angle B is 32 degrees, asking us to find side B, which is over here. And once you draw the picture, it's going to fall into one of these three things up here. For now, we only know sine, cosine, and tangent. The other three trig functions are not an option. We did both possibilities of the variable being on the bottom. Oops, you can't see that. Both possibilities of the variable, two possibilities of the variable being on the bottom, one possibility of the variable on top. So this one here, the equation I have to solve in relation to that 32. That's opposite, that's adjacent, so we got a tangent. So we have the tangent of 32 is equal to the b over the 8.5. All right, that turns out to give us an answer of about 5.3 after the round off. Okay. Next examples here. Sometimes you're using SOHCAHTOA trig to find an angle as opposed to finding a side. Thought process is going to be very similar. Okay, that guy right there, that's the Greek letter theta. Looks like an O with a horizontal line through it. It's a very common variable in the trig world. You're going to see that quite a bit throughout the course. So that's our angle of interest. In relation to that angle, we have adjacent and we have hypotenuse. So adjacent and hypotenuse means we're using cosine. The cosine of that angle is equal to 8/13. All right, so in the problems we did on the previous page, the variable was either the top of the fraction or the bottom of the fraction. Now the variable is the angle itself. When you know this number over here, today it's a fraction, it could be a decimal, what you're going to do is use the inverse trig functions. What you're going to type in your calculator is that angle is going to be the inverse cosine of that fraction. And the notation for that is a cosine with a little -1 exponent. All right, on your graphing calculator, those are the second functions above the regular sine, cosine, tangent buttons. Slide that over like this. So we are hitting second to get the inverse cosine, and then 8 divided by 13. And following the round-off instructions, it says to the nearest tenth again, so 52.0 degrees. All right, another example of that type. We have the angle of interest being down here. That's the opposite. That's the adjacent. So we're using tangent. The tangent of that angle is 13/19. So when we know this number, but not that angle, that's when you're using one of your three inverse trig functions. So what you're typing in your calculator is the inverse tangent of that fraction. And we're going to do problems a little bit later. I don't know exactly where it falls, where that'll be a decimal instead of a fraction. No matter what that form is, the key thing is we know that value on the right. So we have second function, tangent, to get an inverse tangent. We're going to type in that fraction, 13 divided by 19, and to the nearest tenth, that's about 34.4 degrees. All right, last example for this page. When you see the instructions to solve a triangle means you need to find the lengths of all three sides, the measures of all three angles. So we have angle A, angle B, angle C. We know that C is 90 degrees. It's labeled as such. We're told that angle B is 64 degrees. We know that the three angles of a triangle have to add up to 180. So 180 minus the sum of 64 and 90. 26 is our missing angle. Then we have the lengths of all three sides, little a, little b, little c. Again, standard naming convention is the little letter is always across from the big letter. So that 18 is going to refer to little a. So now we have two sides left to find. We have to find side B, we have to find side C. So what I'm going to do is decide which of the two I want to find first. It turns out we can find either one. I'm going to go with B. So in relation to that 64, that's opposite, that's adjacent. So we have the tangent of 64 is B over 18. So B is going to be 18 times tangent of 64. And we get about 36.9 following the round-off instructions to the nearest tenth. Now, when we do these problems, although our final answers are going to be decimal approximations, we would like them to be the best decimal approximations they can be. So, when possible, we'd prefer not to use rounded numbers for future calculations. So that 36.9 is not exactly 36.9. It's that number right there to however many decimal places are there. I think it's 10. So if we can get away with finding C without using that, we would prefer to do that. Now, sometimes you have no choice but to use rounded values, in which case it is what it is. But we can find C without using that 36.9. So what I'm going to do is set up another trig equation. And I'll use the same 64. That's an exact value. I'm going to use that 18. That's an exact value. And find this C right here. So in relation to the 64, that's the adjacent, that's the hypotenuse. So we have the cosine of 64 is equal to 18 over C. Oops, slide that over a little bit. So this is going to be 18 divided by the cosine of 64, and we get about 41.1 to one decimal place. Now, another option to get an answer was, at this stage, we knew two of the three sides of a right triangle. We could have done the Pythagorean theorem, but with the Pythagorean theorem, we'd be working with a decimal approximation, and it may or may not adversely affect the accuracy of this answer, since we can get away without using the decimal approximation we did. All right, last thing I'm going to do with this problem. One quick check you can do with all triangle problems is use the fact that the smallest angle is always across from the smallest side, largest across from largest, and middleist across from middleist. Yes, I know middleist isn't a word, but it's fun to say. So the smallest of the three angles is the 26. The 18 is the smallest of the three sides. The biggest of the three angles is 90. The largest of the three sides is 41.1, and then middle across from middle. Now, that doesn't guarantee that those answers are correct, but it does find a decent number of mistakes. If you made a mistake, like using the wrong trig function, or you had a fraction upside down, or you typed it into your calculator wrong, very often that relationship between the sides would be wrong. All right, next skill set for today. I have to zoom this out a little bit, I think. There we go. There are different ways of measuring angles, just like there are different ways of measuring other quantities. For example, your height, you can measure it in feet, you can measure it in inches, you can measure it in meters, you can measure it in centimeters. Angles can be measured different ways. The two most common general breakdowns are you can measure angles in degrees, or you can measure angles in radians. Most of you, I guess all of you, would have done degrees in geometry, and I'm not sure how far you got in trig with Algebra 2. At the time of the making of this video, I haven't determined how far the Algebra 2 classes got with the trig stuff. So the radians may be new to you. I'm not sure. Now, if you're going to measure in degrees, most of you are comfortable or have done decimal degrees. And that's what we did for the problems we were just looking at. There's also measuring in degrees, minutes, and seconds, which is something new. So that's what we're going to look at. All right. A minute is 1/60th of a degree. A second is 1/60th of a minute, which makes it 1/3600th of a degree. So what you need to do sometimes is convert back and forth between decimal degrees and degrees, minutes, and seconds. So for example, 40 degrees, 24 minutes, 18 seconds. We can convert that to decimal degrees by definition of what I just said. 40 plus 24 over 60 plus 18 over 3600. And then whatever that turns out to be, type that in my calculator, we'll take a look. So 40 plus 24 divided by 60 plus 18 divided by 3600. And then we get 40.405. And if that turns out to be an awkward decimal, just follow whatever the round off instructions are. All right, another option that you have is you can use the graphing calculator to help you out with this. What I'm going to do is type into 40, and I'm going to go to the angle menu, which is the second function above apps. And you can see that first choice is a degree. Then I'm going to type in a 24. I'm going to go back to that angle menu and choose minutes. And then I'm going to type in the 18. Now, one would think that if you're going to create an angle menu in a calculator, and within that angle menu you have degrees and minutes, it would make sense that the seconds should be there as well. But you would be wrong. What you have to do for the seconds is that is the alpha above the plus. Why? I do not know. And that's the alternate way to get to that same decimal measurement, decimal degree measurement. Okay, going in reverse. Okay, what if you're giving something in decimal degrees and you want to convert it into degrees, minutes, and seconds? All right, it turns out that that set of computations is rather messy. We're never going to have to do that by hand. We're definitely going to be using a graphing calculator for that. What I'm going to do is type in that decimal degree, that 37.76, and then I'm going to go to that angle menu, and that choice number 4, the arrow degrees, minutes, seconds, will convert it over into degrees, minutes, seconds. Now, it's possible that that last term, that last piece, that 36 seconds, may have to get rounded. You don't have a clean conversion. Usually one decimal place is fine, or if there is specific instructions, like round to the nearest second, then you would round that to the whole number. All right, that wraps up what you are responsible for from today as far as intro to trig.